All right, so here's plan. Oh, a couple things. I want to show you one thing here I'm doing. This is taking a ton of time, but I think this is going to be helpful to you. If we go to the algebra page, okay, I'm not done with this, but you can kind of get an idea how this is going to work. Okay, so if you go down to, for example, if you go down to the Unit 3 practice, I'm getting this set up so under each assignment or group of assignments, like for each section in the textbook, if you click the resources, it's gonna send you right to a page. Oh, that's not what I wanted to do. Hang on. I think that one's not. Maybe this one works now. Yeah, good. It takes you to a page that's got all the resources gathered in one place, right? So now on this page, if I click text, it's going to take me right to the textbook. Opens it up in a new page, right? Is everybody getting this? If I click, this is the MOS. That's the, what are they called? Math on the spot or something like that. The ones from the textbook. If I click on those, it opens up the little videos from the textbook. Okay. It will also have stuff like yesterday. This seemed like this was going to be useful to people, and so, for example, oh, where'd that go? Oh yeah, right here. So like this one will be the 6.2 resources will look like this. Like there'll even be a section in there that's going to have the notes from yesterday. And so if you open that up, it's just got everything we did in class. Well, that's today actually. That's for the multiplying polynomials. But everything we do in class will be on a PDF there, right? All the class notes. Okay, is that going to help? Okay. I don't want to do it if it's not going to help because it takes time. All right, so anyway, all that'll be a little more organized. So with each section, it'll be easy for you to just find, just click that and go right to the resources. Okay. All right. So we're going to look at multiplying polynomials. This shouldn't take long, and then I'll turn you loose on the assignment. This is exactly what you think it would be when we multiply polynomials. All we're really going to do is just distribute from one to the other, right? There's a couple things that make this easier, though. So in this case, I've got two polynomials up here. One of them has 3 terms and one has 4. When you're distributing, it's easier, I think, and it'll make sense when we go through this example. It's easier to distribute from the polynomial that has fewer terms to the polynomial that has more terms, right? So for example, in this case, let's distribute from the left polynomial to the right polynomial.
So you just distribute and there's your answer.
Well, we're just going to distribute and add like terms. So we're going to distribute, for example, we're going to distribute the negative 6x cubed all the way through this guy, and then we're going to distribute the negative 4x all the way through, and the 4 all the way through, and add up like terms. That's a lot of terms, though, right? So it makes sense for us to do this in that vertical technique that we looked at yesterday, right? So make sure that these are, that these polynomials are written in standard form, so the biggest power of x comes first. And then what am I going to get when I distribute the negative 6x cubed, for example? What's that going to give me? When I distribute that to the first term on the right, what's it going to give me? 48, positive or negative?
Negative.
Negative, so negative 6 times positive 8 is going to give me a negative 48. What about the variable part? What's x cubed times x cubed? X to the 6th, isn't it? Okay, this is different now. When we added them, it's different. When we add like terms, we're just adding numbers of those terms. But when we multiply these terms together, that's different, right? Then we have to use our properties of exponents. When we multiply like bases, we just add exponents, right? So this will be negative 48 x to the 6th. So let's distribute it to the next term. What do we get? Positive.
24.
Well, 6 times, negative 6 times negative 3, 18. Now, what's the power of x going to be? X cubed times x squared? X to the 5th. Good. So that one's going to go in the next column because we have to leave a column for each power of x, right? So that's going to give us our plus 18 x to the 5th. And then finally, I'm going to get this guy. Well, not finally. I guess we got 2 more. This one times this one is going to give me an x to the 4th. What's the number going to be? I'm going over to this one, plus 12, x to the fourth, and then to the last term, I'm going to get an x cubed, so it goes in the next column.
60.
Yeah, plus 60 x cubed. So now we'll do the same thing for the negative 4x. Distribute that all the way through. So negative 4x, it actually makes sense, honestly, to do the variable part first, so you know which column to go in. So x times x cubed is what? X to the fourth. So we got to go in this column, and what's the coefficient going to be? Negative 4 times 8 is, yeah, I heard it, negative 32 x to the fourth, so it goes there. If we distribute to this term, x times x squared is
The third.
x cubed, so it goes in this column, and negative 4 times negative 3. And then we go to this one, x times x squared, negative 4 times negative 2.
8.
And then finally, negative 4x times negative 10.
Negative 40. Oh wait, never mind. Sorry.
It's
40.
positive.
40x, okay. And then last one, we'll distribute the 4 all the way through. Now think about this. We could kind of cheat a little bit here, right? Because we just multiplied by negative 4x. So multiplying by positive 4, how's that going to change all the answers we just got? Okay, opposite signs. And then instead of multiplying by x, we're not going to multiply by x at all. So what's going to be the consequence of that? How are the powers of x going to
They're
relate?
two the same.
Well, as the original.
As the original, right? So there'll be one less than what we got when we multiplied by negative 4x.
Should be 32.
Everybody see that? So we could really, each one of these is just going to give us the term, the green term, right? So it's going to be the opposite of positive 32, or negative 32 is positive 32, and the x is going to be cubed, right? See the little shortcut? This one's going to be minus 12 instead of positive 12, x squared, minus 8x instead of x squared, and minus 40. And now all I've got to do is just add those up vertically, right? So this one is easy. There's only one term. That one's easy. What about here? We got x to the fourths, positive 12 and negative 32.
Negative 20.
Negative 20 of those. How about this one? Let's see. So
Plus
72 plus
104.
104?
Yeah.
To x cubed. And then this one,
Should be negative 4.
x squared. And then how about this one?
32.
And then minus 40, right? That's it. Okay, it's a big process. It helps to line that stuff up vertically. Okay, what if we, oh gosh, where is this? Okay, what about that? So they want us to find the volume. Multiply them all together. So now I'm gonna have to multiply then, they're small, but I'm gonna have to multiply 3 polynomials together. This one times this one times this one. When I multiply 3 things together, I've got to do that product 2 at a time. So I'd have to do something like maybe take this one times this one and get a simplified answer, right? And then that simplified answer is going to be the polynomial that I multiply by this one, right? You can't do them all 3 at the same time. You got to do them in pairs, okay? What about something like this? This one says we can use graphing technology. Okay, what about that? This looks like there's a lot to do there, but it's not that big a deal. So it really isn't. Yes, question?
Will you just combine both of those polynomials together?
We're going to, yeah. So if we read through this one, it says a company produces widgets. The number of widgets produced is modeled by the polynomial, this guy right here. So this is telling us the number of widgets where X represents the number of years after the year 2000. So in the year 2000, X would be 0. In the year 2007, X would be what? 7, yeah. And so I would just plug in 7 to determine, for example, how many were produced that year, right? So this one, once again, gives us the number that we produced. This other polynomial tells us the average production cost for each item, each widget, as a function of X, where X is, once again, the number of years after 2000, right? So they want you to do two things here. They want you to come up with a polynomial model for the total cost, total production cost. And then they want you to use that model to answer a question. But the bigger part of this is number 1. So how am I going to come up with a polynomial for total production cost? Just logically think about that. Total cost of production, if they give us the number of widgets and the cost to produce each widget. If you're wondering what a widget is, and if you ever take an econ class in college, that's what they'll call everything you build is just a widget.
You times it.
You just multiply it, don't you? The number of widgets times the cost per widget gives you the total cost to make all of it, right? So I would have to take the product of that polynomial and that polynomial. That looks kind of ugly, but you can use a graphing calculator. So you can, when you're multiplying these decimals, just put them in your calculator. It's fine. That's going to give me, when all the dust settles, when I collect the like terms, I'm going to get some big polynomial there that gives me the overall production cost. So if I want to try to predict what the overall production cost would have been in 2008, how would I use that model?
You just times it all by 8.
I don't times it by 8. What am I going to do?
Plug in 8.
I'm going to plug in 8 for X, right? Okay, and that'll give me the answer, right? Make sense? Go. You can work. Do you want to see how that trick worked? Did I show you how the trick worked?